Okay, it is a great honor to welcome you at the project conference MAHEPA, which is founded under Horizon 2020 program. Today, this press conference is going to be in the hybrid version, so we will be combining live speakers and online speakers. Today, we are flying towards a new era of aviation, and this era will bring cleaner and quieter aviation. The step that the project MAHEPA has taken towards more sustainable aviation has been a challenging one. But the partnership has successfully demonstrated that by gathering knowledge and experience, great innovations are possible. The project has achieved a great success with the development of two novel, modular and scalable hybrid electric powertrains for aircraft. These aircraft are able to fly on alternative fuels or hydrogen with zero emission. The technology has been integrated into the four-seater aircraft. The first aircraft is a hybrid electric Panthera from Pipistrel, and the second aircraft is a H4 hydrogen fuel cell aircraft from H2Fly company. Both aircraft have successfully completed their first test flights, demonstrating the possibility of having zero-emission flights through all-electric takeoffs. We had gathered here today to share with you the future insights on the projects, experience, and also the achievements, and also the challenges that lay ahead. Several distinguished speakers will join us to discuss the importance of collaboration between university and academia, the environmental benefits that are coming from cleaner aviation, and of course also the importance of SINEA activities for aviation. The partners will give you more information about the project, including what is needed to enable zero-emission aviation. Before I give my floor to the first live speaker, I would like to open this press conference with the first public release of the project video, followed by the welcome speech of Marcelo Romans, which is the head of transport unit at SINEA. So I would kindly ask you to look at the video.
With the constant growth of air traffic, the pressure on the environment is rising, and so the use of alternative fuels and powertrains is becoming a necessity. To ease the negative impact of aviation on the environment and to provide cleaner technologies, Project MAHEPA was launched with the support of the EU Horizon 2020 programme. A team of various experts gathered with one sole purpose: to tackle the challenge of more sustainable aviation. Within the MAHEPA project, two new hybrid electric aircraft were developed. The first one uses a fuel-driven generator coupled with lithium-ion batteries to power the electric motor, while the second relies on hydrogen-fed fuel cells to produce power-enabling zero-emission flight. The MAHEPA Panthera is a four-seat hybrid electric aircraft, a quieter and cleaner version of the groundbreaking Pipistrel Panthera that has captured the minds of the aviation community worldwide since 2013. The aircraft provides quieter takeoff and flies with less emissions than a conventional aircraft due to its much more efficient powertrain. Panthera can reach a maximum speed of approximately 170 knots and can fly over a range of approximately 1,000 kilometers. It took years of work and experience to realize the idea of this aircraft.
The MAHEPA Panthera hybrid electric aircraft is giving us a clear example of how it is possible to fly greener. This aircraft has much lower fuel consumption, emissions, and last but not least, it is much quieter. Thanks to MAHEPA project, we are showing that changing aviation is possible, and we are doing it now.
The second aircraft is HY4, a visionary emission-free hydrogen-driven aircraft. The HY4 is the first four-seat electric aircraft with the most powerful hydrogen-based fuel cell system ever used to fly. It enables completely emission-free flights over short or long distances. The HY4 can reach a maximum speed of approximately 200 kilometers per hour and, depending on the flight profile, can fly over a range of up to 750 kilometers.
Our MAHEPA project gives us the opportunity to develop emission-free electric flight with hydrogen, and together with our partners we can show that emission-free aviation is possible.
MAHEPA project succeeded in flying 2 innovative aircraft and set a clear roadmap for the sustainable future of aviation.
Ladies and gentlemen, good morning from Brussels. Thank you for the invitation to open this event. And thank you to the MAHEPA team in Maribor for organizing it. Unfortunately, I cannot join you in person, but I'm happy that I can record this short message. MAHEPA was an important project for us and for Europe. As head of unit of the Transport Research Unit in SINEA, I would like to start with introducing SINEA and its role in transport research and innovation. SINEA, the European Climate, Infrastructure and Environment Executive Agency, is the successor to INEA, which began its operations in 2008. The new agency that started on the 1st of April of this year has been entrusted with a wide program portfolio to implement, bringing together all EU programs that contribute to the objectives of the European Green Deal. This includes Cluster 5 of Horizon Europe, which deals with climate, energy and mobility research and innovation, the Connecting Europe Facility 2, specifically the parts on transport and energy infrastructure, the Innovation Fund and the well-known LIFE program. With a budget of €56 billion, SINEA will make an important contribution to the realization of the ambitions of the European Green Deal. Within SINEA, the Horizon Europe Transport Unit currently supports 250 ongoing projects funded under Horizon 2020. Soon we will expand this portfolio with new projects funded through the new calls of Horizon Europe, the program that started this year. Our projects cover a broad range of transport sectors. This includes automated transport, electric vehicles, urban mobility, logistics, safety, waterborne transport, and of course, aviation. In the field of aviation, our portfolio consists of more than 100 completed and ongoing projects, and a total implemented EU budget of more than €500 million since 2015. The thematic areas addressed by the aviation projects include climate impact, emissions, electric and hydrogen propulsion, sustainable aviation fuels, air quality, noise, urban air mobility and drones, safety, materials and structures, modeling and simulations, and multidisciplinary design. An exceptional example of an impactful project is the MAHEPA project. By developing, assessing and demonstrating a low-emission, very innovative propulsion technology, the project has contributed to bridging the gap between the research and the project stage for the future generation of hybrid electric aircraft. MAHEPA has actively contributed to the objectives of the European Green Deal. It is one of the transport research success stories of Horizon 2020. I hope that under Horizon Europe we will be able to select projects with similar excellence as MAHEPA, so that we can continue to develop the technologies that are necessary to accelerate the reduction of the aviation sector's environmental footprint, to maintain industrial and research leadership, and to ensure high safety and security standards, while of course always addressing the needs of Europe's citizens. Ladies and gentlemen, I would like to finish with congratulating the MAHEPA consortium with its excellent results. I wish you a successful event and I thank you for your attention.
Okay, I would like to proceed with the program. I would like to ask Rector of University of Maribor, Dr. Professor Zdravko Kačić, to say a few words about the project.
Thank you very much. Ladies and gentlemen, it is my pleasure to welcome you on behalf of the University of Maribor to the MAHEPA press conference toward the new era of aviation. Despite the fact that we are still feeling the consequences of the corona crisis and are approaching the peak of the fourth wave of the epidemic in Slovenia, we are looking to the future with hope for a return to normal life as soon as possible. An expectation that is, unlike last year, this year realistic due to the existence of the vaccine. The situation in the past year and a half has forced us into a different way of life. In many ways, it has defined different patterns of our behavior. It is becoming increasingly clear that this period has left many traces in modern society, many of which will remain among us for a long time to come. And I probably won't be wrong to say that it has had a significant impact also in the areas of the aviation industry and airliners. But every crisis can also be an opportunity at the same time. It can also be a time to rethink the established business standards and consider new possibilities for addressing the problems of modern society posed by the need to reduce greenhouse gas emissions and achieve carbon neutrality. The project MAHEPA, Modular Approach to Hybrid Electric Propulsion Architecture, is a successful example of addressing a number of challenges of the modern world that opens up many new development opportunities in the field of transport and aviation for various stakeholders on local and global levels, and is an excellent example of successful cooperation between industry and academia. I am convinced that today's event is an important milestone in the development of the modern aviation industry and a significant contribution on the way to achieving the goal of carbon neutrality. Congratulations to all project partners for the achieved results, and I wish you successful work also in the future. Thank you.
Thank you very much for these kind words. I would like to ask next speaker, project manager from CINEA, Mr. Hugh Felix, to take us into the CINEA activities, tell us a bit about aviation.
Okay, good morning, ladies and gentlemen. Thank you for this opportunity to introduce CINEA in the picture of aviation research and yes. So I will first give a general overview of the European Commission and CINEA. Then we will go through the different aviation project portfolio and, important for you, the upcoming aviation topics which will be open in Europe. So first, an overview of EC and CINEA. So CINEA, as in 1st of April, we become CINEA. We were initially INEA. CINEA is Climate, Infrastructure and Environment Executive Agency. We support the stakeholders in delivering European Green Deal and adding to transport and energy new programs such as climate, environment and maritime program have been added to the new agency CINEA. So you certainly know who are the main pillars of European institution: the European Parliament, the Council of European Union, as well as the European Commission. Depending from this European Commission, you've got 6 executive agencies based in Brussels, and these executive agencies implement the different programs put in place by the European Commission. And CINEA is one of these executive agencies. So the major task of an executive agency is to first open call for proposal, and you know very well the process, and then you apply for a call, and we select experts, and we proceed to the evaluation and the selection of the proposal that are proposed to be funded with European funds. Then came another phase, important phase, is the preparation of the grant agreements. And after that, CINEA, with support of its project officers. We have to make a technical and financial follow-up. And at the end of the project, we have to give some feedback to the general direction of the Commission. So let's have a look at the portfolio of CINEA. So you know Horizon Europe, which is the successor of Horizon 2020. And so in the case of CINEA, we implement the largest part of the cluster on climate, energy, and mobility, and amounting to 9.6 billion euro. Secondly, we've got Innovation Fund, which reinvest the income from the EU emission trading system, and this fund is about bringing innovative clean technologies on the market. For instance, the production of innovative low-carbon energy carriers, such as sustainable alternative fuel and hydrogen, also their storage and their use for transport. These are all projects which are eligible, and also including air transportation. In fact, Innovation Fund project targeting import infrastructure is possible if focused on eligible areas on renewable energy, energy efficiency, deployment of low carbon solution. And thirdly, we've got another important program. It's Connecting Europe Facility 2, the successor of Connecting Europe Facility. And this includes the deployment of air traffic management infrastructure developed in CESAR program. So it's an instrument focused on deployment. The budget is quite huge, over 31 billion euro. And this infrastructure is important and relevant for airport and in the future also for cities in terms of urban airspace management. So there are different programs also. The Just Transition Mechanism and public sector, which is, gives loan facility for region where transition for a greener economy is a bit more challenging. There is also the LIFE program, which is new to CINEA, the low-standing EU program on environment, and the new renewable energy financing mechanism. Also, there is a part of European Maritime and Fisheries Fund. So as you see, the budget is quite important for Connecting Europe Facility number 2, with a budget over 31 billion euro, and Horizon Europe close to 10 billion euro. Then Innovation Fund and other program with a lower budget but not negligible. So let's have a look at the portfolio of CINEA in aviation. So we have about 100 projects which are either finished or ongoing from Horizon 2020, with a total funding with more than €500 million. The thematic which are covered are quite various, and I will go through some of them, but not in detail, because this is not the purpose of this presentation. And of course, for all of these projects, we aim to go beyond of the state of the art, and we are complementing the GU activities of Clean Sky 2 and the future Clean Aviation. The difference is that Clean Aviation is focused more on high TRL, and we are focused more on lower TRL with a bottom-up approach, and Clean Aviation is as a top-down approach, which is different but totally complementary. And we also support CESAR 2 and the future CESAR 3 in the deployment of the infrastructure in the airport. Okay, let's have a look at some of the topics. One important thing is noise reduction and management of noise. This is just to illustrate some of the many projects we've got for greener aviation. And one of these projects is ANIMA. And it's not only that we look at the noise emitted by the aircraft or by the engine, but also the perceived noise by the population around the airport, and to find mitigation action to reduce this perception. And we have some project on flight and airport operation. This is only a small list of projects. And regarding the monitoring of the air quality, the project Aviator, for instance, is developing and demonstrating new low-cost sensors network, including also participants out of Europe. For instance, Canada is a great contributor on this project. And it is worth noting that the air quality at the of large airport in terms of NOx particulates is not only influenced by the aircraft action, but also by the road traffic nearby of the airport. And this is taken into account in this project. So, another important topic is sustainable aviation fuel and hydrogen. And we've got two main projects, Alternate and Enable H2, which are working on hydrogen use in aviation and sustainable aviation fuel. So another one, very important, is hybrid electric with MAEPA, which is unfortunately finished now, but I hope there will be a follow-up, something in relation with low emission or zero emission in aviation. We've got H3PS, we've got a Footprint 50, and a big one, which is Imhotep, led by Onera. And these two projects, MAEPA and Imhotep, are the key project in hybrid electric research in aviation. There are several projects in relation with UAVs. I mentioned only two here, but there are many more projects. And in this project, we have also participation of EASA. And as I mentioned yesterday, the Pioneer project was MAEPA with participation of EASA as a participant or support. And now this is a common practice to have EASA on board, and it is very important to have them on board with, for projects in relation with UAVs and the implementation of UAVs in, outside of the cities or within the cities. We've got some other project on digital and data-driven solution. These two, Remap and Safe Clouds EU, are two examples. We've got project on icing, which is a critical aspect of aviation. Sense4Ice, for instance, is developing sensor for direct detection and indirect detection, and also hybrid with these two technologies. We've got Ice Genesis, which is creating a 3D simulation or means of icing, and Music Cake, which is more focused on high-altitude ice crystals. For this free project, there is a huge international participation from Brazil, from United States, from Canada, and also Russia. And this allows their own budget, and with the leverage effect, we double the budget available for the project, which is very good. And I encourage you to look for international cooperation with Russia or Canada, and Canada is really willing to participate to EU project with their own budget. So another important aspect is Green Airport, and CENIA has recently signed 3 large demonstration projects from the call Green Airport and as multimodal apps for sustainable and smart mobility, where we have a link between the cities and the region with the airport inside and the airport landside, including the terminal, the green fuel, the hydrogen, electricity production, supply, logistic operation, and so on, and so on, and so on, and so on. So there are 3 projects which have been selected, each of them with an EU budget of 25 million euro. First one is Tulips, with an airport as a lighthouse, Schiphol Airport, and other Fellows Airport, Oslo, Turin, Larnaca Airport, and 15 other entities. And Pipistrel is part of this project, and I hope I'm sure that Pipistrel will bring valuable support to the project, giving a voice of general aviation and the need of general aviation for the airport, and the input for to lower the impact of aviation in airport and surrounding suburbs. We've got also Stargate with Brussels Airport as lighthouse airport, with fellow airports like Athens, Budapest, and Toulouse, and 18 other entities. And the last one is Olga with Paris Airport, and other fellows airport, Milan, Zagreb, Cluj, Napoca, and 37 other entities. So we are also pushing for some synergies between these projects. There is no competition, and each of them will bring a brick to this big house to lower the emission and the and pollution around the airports. And I hope that Pipistrel will be a big player in this synergy. I invite you to look at the recent CENIA publication towards climate neutral aviation, so it's possible to download it. I don't bring any paper copy because you know we try to avoid that, but you download that without any problem on our website. And one important thing is the upcoming aviation topics within Horizon Europe. So we are implementing Horizon Europe in transport and in particular in aviation, and we have managed 3 calls. They are now finished, and you will have very soon the results of these calls. But most important are the upcoming calls, and in particular the D5112 towards silent and ultra-low air pollution aircraft. And the deadline is in end of April, so I guess that many of you as participants of MAHEPA project will be interested to be part of one consortium applying for that call. There's another one, the D5113. It's about digital aviation technologies for new aviation and for services and emerging global threats and industrial competitiveness. The D5114 it's a different call. It's to support the European Commission for the European policies and initiative. So it's a totally different call. And another one is the D617 for more resilient aircraft and increased survivability, but in that case, the deadline is in January. So, in conclusion, CENIA implements all EU programs that contribute to the Green Deal, and we have an extensive aviation portfolio from the heritage of Horizon 2020, but it will grow with the new project in Horizon Europe. And our role in the implementation of the aviation research and innovation is also confirmed in Horizon Europe. And we are pushing technologies and solutions to mid-range TRL. And Clean Aviation joint undertaking is focused on higher TRL. So we are totally complementary. And so there are numerous funding opportunities offered within Horizon Europe for European countries as well as non-European countries with their own funding. So I thank you to have listened to this presentation, and I'm open to reply to any question if you have some, or by email or when you want. Thank you.
Thank you for these kind words. We see a lot of activities going on in the funding and research. We are really happy that MAHEPA was part of this great story, and we hope that we see each other once again on the next call, on the next challenge ahead.
This is my wish, to have such a good team again on board with another project, because it was really a pleasure to have such a project in the portfolio of project officer. Thank you. Thank you for your good job, and I hope to see you for the next one.
Yes. So I would continue with the press conference. I would kindly invite Fabrizio Gaspari. He is the project coordinator at Pipistrel, and he will give more insights into the project, that we will be aware what was the challenges and also the achievements that we set. So.
Yeah, thanks, Masha, for the introduction. First of all, let me thank the airport of Maribor for hosting us. It's a very nice place, very nice windows on a very colorful landscapes around us, and also the University of Maribor for having organized it, because as we said at the beginning, we are living in a quite difficult period, but to have such events in person, it's a complete different story than connecting to WebEx or Teams and waiting for people to unmute their microphones. So thanks, really. So yeah, I will in the next slides go through what is MAHEPA, what we achieved, and which are the main results of this very interesting project. So MAHEPA stands for Modular Approach to Hybrid Electric Propulsion Architecture. It is a 9 million euros project completely funded by the Horizon 2020 program, and it is comprised of 8 different partners. So these partners come from a quite wide spectrum, because we have manufacturers like Pipistrel or Compact Dynamics, a German company dealing with electrical machines. Then we have research centers like DLR and their spin-off H2Fly, both from Germany. But as you can see, we have a lot of university partners as well, with University of Delft, Ulm, Maribor, and Politecnico di Milano. So already from the list of partners, you can understand that the spectrum of the project was quite wide again, and we actually analyzed quite a lot of different things. So I will go through these things, but first, of course, I would like to tell you which were the objectives of the project. So the first objective was actually to advance 2 different variants of low-emission serial hybrid electric propulsion architecture up to TRL 6. So we developed these 2 different systems. One is based on an internal combustion engine coupled with a battery system, while the second one is based on a hydrogen-fed fuel cell system. So after we developed these 2 systems, we actually wanted to fly them. So the 2 powertrains were integrated in the 2 aircraft that you're seeing on the slide. The first one on top is the well-known Pipistrel Pantera, here in the MAHEPA hybrid version, where the internal combustion engine-based powertrain was integrated, while the one on the bottom is the HY4 aircraft, where the fuel cell system was integrated. So we successfully flew these 2 different aircraft, the HY4 last year here in Maribor actually, and the Pantera 3 weeks ago. But since we didn't want to stop here and we wanted to do more things towards always a new era of aviation, we also performed some scalability studies. So basically, from the beginning of MAEPA, we always thought that MAEPA is just the starting point. We want to use what we had achieved and what we developed throughout the project for future bigger aircraft. So these scalability studies were very important since the beginning, and I will show you some insights of this. So to achieve all of these objectives, we had to do quite a lot of things, starting from, of course, new methodologies. So as the name of the project suggested, we started from a modular approach concept. So basically, we wanted to understand which are the common building blocks of all the types of hybrid electric powertrains. So we identified which are the systems, how they talk to each other. So this enabled us basically to create various architecture in a, let's say, shared and understandable way. So then after, from past experience, we understood that cooling is, of course, very important on conventional aircraft, but on hybrid aircraft is eventually even more important. So we put quite a lot of effort in understanding how to model as much as possible the cooling systems. And as you will maybe see after with the Pantera aircraft, we actually have 7 different cooling circuits on one single aircraft. So you can understand that it's quite important to model these systems in the best way as possible. DLR also put a lot of effort in understanding how to actually build up a fuel cell system and a powertrain based on a fuel cell system, because there are different ways how to architecture it. So they came out with this flex fuel cell hybrid architecture that enables, that improves safety, but also efficiency. I will not go into details, but that was one of the very good achievement of the project. And then, of course, we also had to see if what we developed actually is emitting less than a conventional aircraft, because we can make the best powertrain ever, but if it pollutes more than conventional powertrains, then we just did a nice design, but nice design game, but nothing really changes. So we performed some emission measurements on, at Ulm University. Methods didn't stop only on technical details, but also we explored some more economical aspects with market demands estimation. So we wanted to understand if a possible microfeeder or mini liner service with maybe 19-seater aircraft could have actually the potential to attract people, to attract passengers to fly with this novel, let's say, service. So Politecnico di Milano in this case tried to understand which could be a potential catchment area for this novel service, and I think their results are very interesting, very promising for future different mobility. And of course, together with this, also ground infrastructures at airports will have to change in order to accommodate hybrid aircraft in the future. So analyses were done also on that side. From methods to components, of course, I will not spend too many words here because I have more detailed slides later. But of course, we had to develop everything from scratch. Of course, there was nothing on the market ready to be implemented on our hybrid aircraft, so everything was developed and, designed, developed, and manufactured from scratch. From the electric drive to the so-called power generation module, which is basically the module that connects the internal combustion engine to an electrical generator, to a complete renewed and redesigned fuel cell system with improved performance and safety, and then to liquid-cooled batteries that had to be integrated in the Pantera wings, and this integration was not, let's say, the easiest task ever, so it took quite a lot of effort to put these batteries inside the wings. So a little bit more in detail, I will spend a few minutes about the electric motor we developed through MAEPA. I consider this really as a jewel or a masterpiece of the project, because it is actually a dual motor, because we have 2 different electric motors that are mechanically and electrically completely decoupled. So in case of one motor failure, the other can still spin the propeller, so you can still perform a safe landing. So safety was always the first objective of the project, even if it's a demonstrator, of course, safety first always. But as you can see, this electric drive is not only safe, but it's also quite powerful, with a peak power of 300 kilowatts, which is actually 50% more than what we had in the previous projects, and it's also very lightweight. So these characteristics, again, are telling us that these, the MAEPA results could be easily utilized on future aircraft, maybe on a distributed electric propulsion architecture. So again, MAEPA is giving a bit the basis for the future of aviation. Together with the electric motors, there is always a power controller. I will not spend many words here, but again, very, very high power, peak power, and again, with a weight of only 7 kilos. So this can be really easily utilized more or less wherever we want. Batteries, so as again I said before, they are integrated in the Pantera wings. Each battery has a peak power of 75 kilowatts and with 60 kilograms of weight. And this power enables the Pantera aircraft to perform all-electric takeoff. So this is extremely important for also social acceptance of hybrid electric aircraft. So this is a peculiarity actually of this new aircraft that could actually contribute to lower noise emissions and in general emissions in the proximity of airports. So this all translated into flying Pantera. So we first, of course, had to go through high power ground testing, where we tested all the functionality of the aircraft, and we successfully flew, as I said, 3 weeks ago in Cerclier. We reached a takeoff power of 220 kilowatts during the ground tests, and this is actually more than the conventional Pantera. So performance of the hybrid version are actually outstanding, I would say. This was about the internal combustion-based hybrid aircraft we developed through MAEPA, but of course we also did the fuel cell system and the fuel cell powertrain. So the system itself is composed by 4 different fuel cell modules with a total power of 48 kilowatts. And the reason why we have a line with 4 modules is also because in case, again, of a failure of a single module, the remaining 3 ones can still provide enough power to safely land at the airport. So again, safety was really one of the key objectives of the project. It was not easy to integrate this in the aircraft. Structure had to be changed in the central wing. The cooling system, because of what we had experienced in the past, was completely redesigned and improved. So a lot of effort was put in this aircraft and successfully flew in Maribor, actually. I think you recognize the landscape of this picture. The powertrain reliability was proved in flight. The performance actually of the aircraft were increased quite a lot. So with this, let's say, second or third generation of fuel cell systems, really we put the technology one step above from the past. So I think this is a great achievement, and we were able to show that flying zero emission is actually possible now. So I'm about to finish, more or less. So these 2 aircraft flew, okay, and then, as I said, we also focused on scalability studies. So Polytechnic of Milan and Delft, they basically ran a design competition, let's say, where they tried to understand which was the best way in order to use MAEPA technology on future bigger aircraft. So on a distributed propulsion case or on a concentrated case, the universities tried to understand which are the pros and cons of these possible future aircraft. Why this? Because we truly believe that, again, MAEPA could pose the basis for the future transportations, where we really believe that there are smarter ways to travel around Europe. So we could use, for example, underutilized airports to fly from your home, maybe in a small city, to big airports where you can take after a big aircraft to travel all around Europe. So if you want to achieve this 4-hour door-to-door objective that we want to achieve, we have to change a bit the way we think about mobility. So why not using an aircraft like this, maybe utilizing MAHEPA technologies to fly from smaller airports to big hubs, where then we can go maybe to Brussels to have a meeting with the project officer. So this was a bit the question we always try to answer in MAHEPA, and I hope with this brief presentation to have given you an overview of the project. Thanks for your attention, and if any question, I'm available.
So thank you, Fabrizio Gaspari, Project Coordinator of Project MAHEPA. The next speaker is also coming from Pipistrel Vertical Solution. I would like to welcome Dr. Tine Tomažić to give us a bit of vision in the future how the transportation is going to be almost zero-emission flying. So.
Good morning all, including the virtual viewers. Thank you for dedicating your time to us and to the opportunity of looking into the future together with the MAHEPA consortium. So, despite my capacity as the CTO of Pipistrel, today I will speak as a proud member of the MAHEPA consortium, the complete group of excellent people who made this happen. And they asked me to speak about what enables the future of clean air transportation from here onwards. So Fabrizio gave you a look in what was achieved in the past 4 years. So my job is more interesting, I hope. It's because you cannot blame me for making some interesting assumptions here. But before we go there, we have to remind ourselves where we began. This was a slide from the very first presentation on a MAHEPA kickoff meeting, which set the grounds for what needs to be done. A powertrain that could live in different aeroplanes' shapes and forms, a powertrain composition with multiple elements that can scale and live also outside of these flying laboratories. Some people said we are absolutely crazy. Today they still say that we are a little bit mad, but this is quite a transition for a 4 years period. So we made it happen. It was the people who made it happen. People who believed 4 years ago that it could be done, and they did it. Why does this matter? In the innovation space in aviation, you see many images circulating, concepts, ideas. Inevitably, some will succeed, some will fail. These are images that were circulated around in the public domain at the moment MAHEPA began. Only 2 aeroplanes from these images actually took flight. Maybe it's not a coincidence which 2 aeroplanes took flight. It was the H2 Fly's HI4 and Pipistrel's Pantera, but not because of themselves, but because of the power of the consortium and the power of belief. So usually when we speak about these matters, how to go in the future, 3 core pillars are always discussed. It's the same story all over again. Do we have proper technology? Can we certify it? Meaning, is it safe enough? Is it acceptable? And how do we operate it so that this is not only achieving some grander goal, such as making aviation cleaner and less noisy, but also profitable. Let's face it, money turns the world around. So what makes me happy is that because of the turbulence that MAHEPA brought into this field of aviation, not only for small aircraft, also larger ones, there are today many standardization development groups under SAE, under ASTM and EUROK, and there is today approximately 500 people volunteering to write standards that future aircraft, small or large, will be able to employ on the path to certification. So one could say it's inevitable, it will happen. Technological maturity You've heard Fabrizio. Approximately 50% improvements across the board in 4 years' time. Imagine a car that would have half the fuel consumption 4 years from today. You'd be pretty excited about that, I suppose. So what was done is meaningful. So the real question as we go forward is perhaps not whether the technology is there or whether it can be certified, because it's pretty certain this will happen, but how will these machines and technology be operated? What enables that? And most of all, were the assumptions taken 4 years ago when MAHEPA was launched perhaps incorrect? The rationale why there's 2 very different aeroplanes in the project was because it was unknown what's the better direction to take for the future of aviation. These kind of projects, supported by the European Commission, permit the industry, the academia, the startups and the visionaries to figure out collectively what works and what doesn't. So you will see certain components and solutions from MAHEPA make its way towards the future of aviation, but certain will not make it. And this is what innovation is all about. Fabrizio set the stage about moving around in different ways when it comes to flying in the future. I'm sure you have heard about flight shame. A girl from Sweden telling people not to fly, yet taking a carbon fiber boat that took quite a lot of CO2 to produce across the ocean. These statements are powerful, but the solution is not to stop flying. The solution is to use new technologies to keep flying in a much cleaner and better way for the planet. It is the ability of air travel that connects the world, and it is the ability for people to meet face to face that prevents conflicts, that makes wonderful things happen, and has prevented wars for the last 7 decades. So how about the famous 4-hour door-to-door journey time in Europe? This goal was actually set almost a decade ago by ACARE. And of course, we had this on our radar with MAHEPA already when we proposed the project to happen in the first place. It turns out that most of Europeans and international passengers today fly from 70 airports in Europe, 70. It takes 7 people and their fingers on their hands. Today, we are at an airport. How many of you in the room flew here? I see no hands. Isn't this a bit bizarre? Isn't it about time to change this so that all of the disused assets we have, all of the other airports that exist and are not actively utilized for air travel could show their potential? It turns there is more than 3,000 of them available. So what's wrong with European air travel system that these airports are not being used? What's the missing link? And it turns out there's no proper machine to utilize these airports for air travel. It turns out that these airports have relatively short runways for the most part, yet they are also located relatively close to these famous 70 airports I spoke about. MAHEPA introduced new terminology into the field of aviation at its inception. Nobody noticed. The miniliner and the microfeeder. But today, CESAR 3, with its Strategic Research Innovation Action document, has adopted the miniliner as the de facto descriptor of what these smaller aircraft connecting smaller airports would be doing. So something important happened, a shift of belief. So this is basically just a few candidate opportunities, all the yellow dots that could be connected by themselves with a proper machine. It turns out they are not only in Italy, they are all across Europe, and they create an incredible opportunity, not only for the climate, cleaning up aviation sooner than the big 100, 200-seaters will become zero emission, but also to increase the quality of people's lives. To be home sooner in the evening with the people you love, instead of spending time at those 70 airports, queuing, waiting, and wasting your money at duty-free shops. What enables that? It's the people. You all out there are the enabler of how we will fly in the future. We have to solve problems collectively. How about security? How about safety? Not only on the aircraft itself, but how do we see airport security in the future? Where do we do it? This was also points that were communicated from the MAHEPA consortium to DG Move and other stakeholders all the way up the ladder in the European community. But going back to the machines, because machines also need to be created. And this is where the seeds from MAHEPA come from. New tools for a new job were created. It's a matter of putting them together and utilize them. And I would like to give you a few illustrations. This is an opportunity for a 20-seat aeroplane the size of a minibus that flies zero emission all across Europe, connecting any of the 3,000 currently not utilized airports. You see MAHEPA badges all over the place, because technology that was developed under MAHEPA can plug in directly into these products. Fuel cells, batteries, engines. Technology is ready. It's a matter of maturing it, proving, certifying, but it's out there. What's not out there is the path towards even bigger aeroplanes. And this is why we will continue to connect with the industry, academia, and other stakeholders to make sure that the knowledge obtained under MAHEPA doesn't remain with MAHEPA, but goes onwards. What's also amazing is because of the modularity of the whole concepts, very different aircraft look and feel for the future can be enabled, giving aircraft different character. Faster traveling speeds, shorter runway capabilities for takeoff and landings, all with the same engines, same batteries, same fuel cells, just arranged in different combinations. This is the power of hybrid electric aviation. So I hope that next time we meet, out there on the tarmac, through the windows, we could see something like this. We could see mini liners, zero-emission aeroplanes that would actually take us home by the air sooner, faster, and way cleaner than ground mobility means. This idea could also be deployed on much smaller airports than what Maribor Airport is today. There's grand ideas around already coming from distinguished operators. And the big airports will be going through a transformation of their own, embracing flights from small airports to large ones to enable long-distance air transportations of the future that is cleaner, faster, and cheaper. So I'm thankful that MAHEPA was given the opportunity to build up a collection of building blocks that enable the future. For me, these are Lego bricks. And let me tell you what, it makes me most proud that Europe noticed, that the image, the vision that Fabrizio flashed is now showcased as a candidate aeroplane, growing innovation from small to large aeroplanes, piece by piece, so that in 2035, you all will enjoy zero-emission flights in a very big aeroplane flying across Europe. This is why we are doing it. This is why we spent 4 years on these topics in such an amazing audience. Thank you very much.
Thank you very much. It was really nice to look in the future. I hope things will happen. Now we are continuing with the last presentation, which will be online. It's from Professor Josef Kala, and he will explain a little bit more about the hydrogen aircraft that was developed. So I will give my floor to you, Josef.
I have to apologize. I cannot travel to Maribor, but I am very, very happy to be part of this conference here. The last 4 years were very interesting for us and very challenging, and we had a lot of new developments during these 4 years. So I will take you after Tine and Fabrizio on a small journey what is possible, what we have learned from MAHEPA to go bigger, to go faster, to change aviation, to make aviation completely emission-free. So what is the vision of H2Fly? And I have to say some words also on the startup H2Fly. So first of all, H2Fly is a spin-off out of the DLR starting in 2014, taking responsibility in MAHEPA for the safe build-up of the fuel cell system and the fuel cell system architecture. And together with German Aerospace and Center and with the University of Ulm, we reached a new state of propulsion in the fuel cell area, coupling that with hydrogen storage and implementing that into a plane HY4, which is now owned by H2Fly. So H2Fly was a first, how should I say, crystallization point, which now will grow. And not only we have learned from a technological perspective what is important to do, but we managed to get financing. So out of this MAHEPA project, we can say that also new jobs came out, new high-tech jobs. I will show you something on that later. And we have the possibility to grow very fast due to the very good environment in Europe and the cooperations. And we have a chance to go into transport, aircraft transport in the region of up to like 40 to 70 passengers. And with that, we have a chance to go and change the whole aviation. So let's look at goals which we can achieve based on this new emission-free technology. What we see is that if we take a range of 2,000 kilometers and the results out of the MAHEPA system shows that it is possible to have an efficient zero-emission powertrain with fuel cells, which allows, and now it is also important, with a classic design, to go up to 2,000 kilometers. So we could save, from a first perspective, just by changing the propulsion system to zero-emission fuel cells, we could save 63 million tons of CO2 when we compared it with 2018. And this would be a respect of 42% of the aviation's emissions, which we see in Europe. So just by going forward with this technology, we have a chance to change aviation. So what is our goal? Our goal is to say we have to upscale. So if it's 1 megawatt, like showed before, or if it's 1.5 or 3 megawatt, we think that we can build up, test, and qualify propulsion systems up to like 2 times 1.5 megawatt to propel a 40-seater, which can go 2,000 kilometers with zero emission on the CO2 side. So in this case, we can proudly say that the complete effort of all the partners in MAHEPA led to the technological driven decision to say we go into real transport capacity. We are not staying with a 4-seater or like a 2-seater. We will ramp up the technology and we will go so we can have transport capacity using new airports, regional airports, but also using the airports which we already have today. So just summary on the MAHEPA achievements, we achieved a maximum theoretical range of 1,200 kilometers, 750 is definitely feasible. We have a permit to fly from all together, all the partners we're working very good together. I have to say, this is one of the few projects in which all the partner on a working level put together the maximum effort to get to the goals. So I'm very, very happy to be part of this team. And in this case, at this point, I have also to say, last year in November, December, we had the maximum of the really bad wave on COVID in whole Europe, and all the partners from Pipistrel, from H2Fly, from DLR, from the University of Ulm, from University of Maribor, went to Maribor, and we had a couple of weeks. Nobody went home. We stayed in quarantine and worked focus on this to achieve the goals. This is personal achievement and personal commitment. So thank you very much for all of those who took this part on developing and also realizing this. So now, what could be a major way forward? So from our perspective, definitely 110 kilowatt prototype HY4 zero emission fuel cell powertrain is a learning to get the system propulsion architecture, to understand where to change the components, to understand where it's important to have a safe system, where to do the achievements so we have a reliable but also a system which we can produce. Then what we definitely see is that we have to go to much higher performance of the systems. So the next steps would be to go into much higher power, but very important just to mention, the next step would be the liquid hydrogen storage system in Project Heaven, which is also a EU project, and then to go up from there to megawatt scale. No matter if it's 1 megawatt, 1.5 or 3 megawatt, but the important thing is here, we have to go to upscale and go into megawatt scale. This is the challenge, what we learned. And I do not want to minimize the achievements of Mahepa because this is very, very important. But we want to learn from Mahepa. And the major learning of this is we need megawatt scale propulsion systems to do transport capacity from regional airports or from the airports how we know them today. Then we plan for today a megawatt scale demonstration in the region of 1.5 megawatt in 2026, and then starting commercialization in 2028. These are very important goals because what we see is we have to tackle integration challenges on the aircraft level. So from our perspective, H2Fly, we see that a classic design of an airplane or an airplane which is very nearby to a classic design will be the only way from today's perspective to achieve the goals fast. So in that case, we need a lot of cooperation Europe-wide to understand what is fancy to have, what is very important to have, like Tina showed before, and what is the minimum base which we have to go into a first product. Because I think here the time base is very important. If we wait 15, 20 years from now to implement this propulsion systems, that is too late. We have to be in a range between 7 and 10 years to get to a first qualifiable overall product. This is from our perspective a very important message. Then on the system integration, propulsion system integration level, we need a lot of work when it comes to the high performance and also the coupling with the liquid hydrogen. And then taking care of the safety, we have to go on the subsystem and component level to produce, so to develop and produce reliable components. So Mahepa was perfect teaching, perfect project to learn, I would say, accelerated and to show and demonstrate. But I'm so happy. I can tell you, these are so interesting times to go forward, to move forward, to achieve goals. And we think from a component level to the subsystem level to the integration level, we need coordinated projects. And I'm very happy to be part of Clean Aviation and also the Clean Hydrogen Initiative nearby of all the initiatives which are coming up now, which also Felix mentioned before. So in this case, I'm very, very happy to say, I think we can do this. I think we can go and upscale and do transport capacity by aviation from regional and from intra and inter-regional aircraft, so airports, to go and do and change aviation. So what are the challenges? Definitely integration of the fuel cell, of the cooling, of the hydrogen storage, of the electric motor, then build up a qualification and certification base, do the energy management and the distribution, and then go on infrastructure in refueling, operation and safety procedures. And I'm saying this very straight. We learned very much from Mahepa on a 100, 200, 300 kilowatt range, but now we have moved up. We have to go to megawatt scale. We have to deal with kilograms per second of hydrogen, which go from a storage system to a storage tank in the plane. We have to deal with boil-off in the kilogram scale, and we have to be honest with us how to minimize that boil-off. We have to take care about how to deal with speeds. Can we go very fast, or will we stay around 600 kilometers an hour? So these all are parameters from the integration to the components we have to take care of. But as an engineer, I can tell you, I'm not afraid of it, because I learned from Heaven, from Mahepa, from all the national projects we had, from the corporations in the last 15 years. We are ready to go and change aviation. So just a very small part on H2Fly. Currently, more than 30 people hired. January 22, we will have 40 people. Then in January 23, we plan to have more than 90 and then scale up to more than 150. So we will definitely be ready to go into the upscaled propulsion systems, zero emission propulsion systems. And at the moment we are hiring. I just want to give you just an impression how valuable these achievements from Mahepa are. We had 6 open positions for 10 days. In those 10 days, we achieved 450 applications from young people, from skilled people, from interesting people. So from all over the world, but mainly from Europe, to be part of this journey. So what I can say is I think we are on the right path. So there is one point which I would like to move on and speak in this. We can change aviation. We can do a new propulsion system. We can do a new integration. We can build airplanes. We can do the infrastructure on ground. But I have to point out, we need hydrogen for it. And in this case, it's not like we drill a hole into the ground and everything will just come out. We take the hydrogen and we use it. This is the way as we know it today. This will change. So from a fuel perspective, we have to understand what is the renewable energy which we need to move forward, build those airplanes, but also have the fuel. And in the same word or in the same sentence, I would like to point out what is the financial effort which we need to build these new airplanes and the new infrastructure. And I would like to take you on a very, very small micro journey on this to tell you, if we want to change aviation, then we have enough money and there is enough capacity to change it, comparing it to the world which we have today. So let's look at where the energy is coming from. I think everyone knows this slide. It's a slide out of the McKinsey study from 2020 from Clean Hydrogen and Clean Sky. It tells if you take a fuel cell with in an airplane or a combustion of hydrogen coming from liquid hydrogen and use that directly, we can go with a fuel cell up to like 4,500 kilometers, with a combustion up to 10,000, with a syn fuel. So not with fossil kerosene, but with syn fuel, we can go up to like 20,000. Definitely implications, current architecture and infrastructure available on the syn fuel side. A lot of work to be done on the hydrogen side. Climate impact, I do not have to tell you numbers, 30 to 60 on the syn fuel, 75 to 90 on the hydrogen side. Noise vibration on the fuel cell side, I would say perfectly. If you start nearby, so if you sit nearby a starting HY4 airplane, probably I have to tell you the plane is starting now, please look at the plane. This happened already in 2016 at the airport of Stuttgart, where we had 150 people sitting there and looking at the airplane, and they heard almost nothing. So the possibilities of the electric drive with the fuel cell is huge. But now I'm coming to the point. I'm not talking about all the numbers on the cost of the fuel. That is something which will change in the future. I'm talking about the energy. We need 1.7 times the energy from renewables if we want to fly with the units of energy in the plane. If we go on the syn fuel side, we need 4.6 times energy if we want to fly with 1 unit out of that energy. So what does that mean if we want to understand how much we have to invest on the primary energy side? That means that if we take, and here you see the required annual capacity, energy capacity to power today's intra-European air traffic, less than 2,000 kilometers by regenerative fuels. Here in the middle, we have LH2, including the production, the storage, and the handling. And here we have the syn fuel. And if you compare that, we need installed power so we can produce 370 terawatt hours of energy out of primary renewables. If we go with syn fuel, we need 960 terawatt hours. Okay, I'm not so good with these big numbers. What does that mean in money? To install so much renewable power so we can get yearly this energy, we need an investment of 280 billion euros. When we want to use syn fuel, it needs 740. So I want to point out there is a difference between 740 and 280. Let's take 400 billion. For those 400 billion, we can build an infrastructure for hydrogen. We can develop a lot of planes, taking in account 2 billion per plane, per model, a bigger one. We can develop a lot of planes, and we can do a lot of work to promote and install the hydrogen emission-free economy. So I want to be very straight on this. Please do not go there and say, this plane is a classic plane with a burning kerosene gas turbine. And I'm looking at this, I put 5% synthetic fuels into it, and that's fine for me. That is not enough. It's not enough to put 50%. It has to be 100%. Our goal, our achievement should be set at 100%. And then we have to look at where the energy is coming from. And I want to say, if we take the hydrogen part, it will be cheaper from a total perspective, where the energy is coming from, where the energy is used, and it will be cleaner and it will be quieter. So with this, I would like just to finalize my presentation and say, I think we all can move forward. I'm very confident. The technical team is good. And my feeling is that the next 10 years will change aviation. Thank you very much for all the MAHEPA team. Thank you very much for all those who are in the room and at the online meetings. And I'm happy to take questions.
Okay. Thank you very much, Joseph, for this really nice introduction. I will propose that we do the closure speak by Fabrizio Gaspari, and then we open also the session for any questions to be answered. Okay?
Yeah, so I didn't prepare any speech actually for this final brief conversation, but again, I would like to thank everybody. It was, I think, a great event. We had the opportunity to show you a bit of what we achieved and which are the future challenges. So we have the opportunity now to see the Pantera aircraft down in front of the airport. So I would really like to welcome you downstairs after the questions, if any, so you have the chance to see a bit of, in real life, what all these presentations actually mean. That's it. I'm very open to answer any questions. Otherwise, thanks again for everything, for the great event, and I hope to see you again for the future challenges. Thanks.
Is there maybe any question from the audience? No? Okay, then I propose we continue. We close the press conference. Thank you for your time, being part of this story, and I hope you will know more about the project now and also keep us updated. Okay, I will kindly close you. We have also a lunch here prepared for you, and we have option also to see the hybrid electric Pantera. Thank you.
Thank you very much.